So far we've looked at how we multiply numbers with exponents. Now we're going to take a look at how we go about dividing numbers with exponents. So one thing to begin to look at is to say, if I have 3 raised to the 4th power, and I want to divide it by 3 to the 2nd power. One thing to remember is that an exponent tells you how many times that number is being repeated. So 3 to the 4th would be 3 written 4 times, all being multiplied together. And I'm going to divide that by 3 squared, which is 3 written twice, multiplied together. If I go to simplify this, I've got 1 3 on the top, 1 3 on the bottom. So that would be simplify out. Sorry, that was supposed to be a 3, not a 2. So then I would simplify also the second 3. Okay. So this would mean that I'd be left with 2 3's on top, or in other words 3 squared, or that's equal to 9. What happens mathematically, or a quicker way of looking at this, is I start with the 3, I start with the 4 that's on top, I'm going to take away 2. So it's like thinking I have 3 4's on top, 2 on the bottom, so if I take these 2 away from 4, I'm going to be left with 3 squared. Okay? So basically what I'm doing is whatever the base is, I'm going to do the top number minus the bottom number to get my answer. Okay. What this fits into though is where we began, of saying, well, 3 to the 3rd power is going to be 27, 3 squared is 9, 3 to the 1st power is 1 3, so it's going to be 3. If I can look at this saying I subtract 1 from the exponent each time, so my next one would be 3 to the 0 power, that corresponds with dividing this number by 3. So 27 divided by 3 is 9, 9 divided by 3 is 3. This would follow that 3 divided by 3 would give me 1. This is an important concept, that any base raised to a 0 power is going to equal 1. So any non-zero number raised to the 0 power is going to equal 1. But then I can go further. Well, what happens if I subtract another one and make 3 to the negative 1st power? If I divide by 3, I get 1 divided by 3, or 1/3. I continue going. 3 to the negative 2nd power. Well, what's 1/3 divided by 3? Isn't that like saying 1/3 times 1/3, using the keep change flip rule? In other words, 1/9. And doesn't that really make it 1 over 3 squared? Okay, so this is going to be another important concept. So here I have the base to the 0 power is equal to 1. And what I find out from these things is that any number, let's say a, raised to a negative exponent is going to be equal 1 over that same base raised to the positive exponent. Okay, so this quantity will also become important. Why does this make sense? Let's go ahead and take that same example we had before. Let's just switch. Let's have 3 squared over 3 to the 4th power. So if I look at this in the same method that I used originally and had 3 squared equaling 3 times 3, 3 to the 4th equals 3 times 3 times 3 times 3. I can simplify 1 3 on top, 1 3 on the bottom, 1 3 on top, 1 3 on the bottom. Therefore, I'm left with 1 on top, because I can think about that as being times 1, over 3 times 3, in other words 9, or 1 over 3 squared. Using my shortcut method, if I have 3 raised to the 2 minus 4, that's going to leave me with 3 to the negative 2nd power, which I could then say is 1 over 3 squared or 1 to the 9th. Either way of writing this is appropriate. So we talked a little bit about negative exponents back at the very beginning, but it indeed comes true as well. Another just little, okay. Anytime I have a coefficient, a number in front, followed by a variable with an exponent, this really means 3 times x squared, and there's an unwritten exponent of 1 on the 3. So if I had 3x squared times 4x to the 6th, I would need to treat as 3 to the first times x squared times 4 to the first times x to the 6th. So in reorganizing this, I would take the 3 times the 4 and get 12. And then I would look at the x squared times x to the 6th and get x to the 8th by adding those exponents. Okay. The same sort of concept is going to apply with division. If I had 16x squared over 8x to the 6th, what I would need to do is almost split it up like this. Okay, treat the numbers as a fraction. So 16 over 8 would leave me with 2. Okay, 8 goes into 16 twice. And then I would treat it with the x squared over x to the 6th. I have x to the 4th down the bottom. So I almost think you can almost think of it like you have 2 x's on top, 6 x's on the bottom. I have 4 more x's on the bottom than I do on top. From a strict mathematical point of view, what you're doing is x squared minus 6, x to the 2 minus 6, getting x to the 4th is going to be 1 over x to the 4th. Okay, so this is what we're going to do some work with, and this is about how we do them.